Welcome to the video session on stack data structure. This is Dr. Sweetney Hemlata from School of Computing Science and Engineering, VIT, Chennai. Let me start with some real-world examples. Here you could see a set of folded shirts, a pile of shirts. Now, where would you place this next shirt? Obviously at the top. Also, whenever you want to take any shirt, cannot take any shirt randomly. What shirt will be accessed next will be that one on the top. Similarly, another example, here you could see a pile of plates. Where this plate will be placed? Again, it will be placed at the top. Whenever you want to access any plate, the one on the top will be accessed next. So in these examples, you could see that whenever you want to place an object into a set, it is happening at a point called top. Whenever you want to remove any object, that is also happening at the same point called top. This kind of organizing the objects that facilitates both placing and removing of existing object at a single point top is known as stack. So stack is a linear data structure where both insertion and deletion are performed at a single point called top. In stack, we term the insert operation as push and the delete operation as pop. So you could see that in this data structure, whatever element has got inserted recently will be available at the top, and that will be the next element to be deleted. Means that whatever element has been placed last will be the first to come out of the stack. That is, it follows last in first out policy, denoted as LIFO policy. Coming to the stack ADTs, the three most basic operations that are performed on stack: push, which takes two arguments, the stack S and the element to be pushed X. Pop, for deleting the topmost element, it takes only the stack S as the parameter. Another method is top, which again takes stack S as a parameter and returns the topmost element in the stack S. Now let's see the demo of push operation in stack. Let me start with an empty stack. The stack S has a maximum capacity of holding 4 objects, and it is empty now. So empty stack where the top will be 0, because from the first location till the last location there is no entry here. Now we want to insert 1, 2, 3, 4 inside the stack in the same order specified. Now let's see how this happens. So starting with the empty stack with top equals 0, now there is a call for push function with the stack information as S and element as 1. So what should happen on push? Now the top is pointing to first location, then the first element is placed at that index. Now there is another call to push for inserting the next element 2 onto the stack S. Again, when the new element is inserted, the old element will no more be on the top. So the next top will be the second location where the next element 2 gets inserted. Similarly, the third element, the top is now incremented and pointing to the next location where we have the third element. Now 3 is on the top. Now 4, we again call the function push to insert 4 onto the stack. Again 3 is no more on the top, we have 4 on the top. Now at this stage you could see that the stack is entirely full. Now if there is a call for the function push for inserting some element onto the stack, what will happen? Top will be again incremented, but it goes beyond the capacity of the stack. So you have to alert that stack overflow, that stack is full. So you have to handle the stack overflow inside push. Now coming to the pseudocode of push. Before we push any element onto the stack S, we have to check whether the stack is full. Only if it is not full, element can be pushed. So we check for the condition of full stack by calling a method is full. If is full returns true, then you can print an error message saying that stack overflows. If it is not full, what do? We increment the top and we place the element at that index. How is full can be defined? Here you could see the definition of is full. When do we say the stack is full? When the top index is equal to the maximum capacity of the stack. We say that the stack is full. In that case, we return true. Otherwise, we return false. Coming to pop, here you could see the demo on pop. Again, I'm starting with full stack. I want to delete all the elements in the stack. Let's see how does it happen here. Starting with the full set, for deleting any element, I have to call the function pop. Now, which is on the top? Top is pointing to the topmost element where we have 4. That is the topmost element. Now there is a call for pop. So pop, you need not pass any element explicitly for deletion because pop always delete the topmost element. So here we have 4 on the top. With a call to pop, it deletes 4. Means that this is not at the top. Now after deleting, 3 will be on the top, so we have to make the top pointing to the element 3. Now the next pop will delete the current top. What do we have on the current top? It is 3 on the top. Now this is no more at the top. After deleting 3, we should have top pointing to element 2. Again, call for pop. 2, which is on the top, will be deleted. This won't be no longer at the top. So now top we have 1. Again there is a call for pop. Now the 1 which is on the top will be no more on the top, means that the top will be going 1 less than the first location, means that all the elements are deleted. At this point, if there is a call for pop s, you cannot really do any deletion in the empty stack. So it should alert with an error message that stack underflow. So pop has to handle underflow situation. Coming to the pseudocode of pop, as I told, we have to check whether the stack is empty. If it is empty, you can print it is error stack underflow. Otherwise, we decrement the top so that the top will be pointing to the element which is below the current top. Now, how do we define the stack empty? When do we say the stack is empty? When the top value is 0, we return true. Otherwise, we return false. The definition of top is top method is used to return the topmost element. There won't be any change in the top index, but only the element that is indexed by top will be returned. So again, for returning the top value, the stack should not be empty. So again, here we check the empty condition of the stack. So if the stack empty is true, then we print error underflow. Otherwise, the stack is not empty. Whatever is indexed by the top in the stack is returned. Hope you would have understood the concept of stack data structure. You could watch a demo video on mapping of pseudocode to C implementation with array implementation of stack in part 2. Thank you.